Hello friends, welcome to engineering tutorial. Now in my previous video I discussed about the various configurations or connection modes of bipolar junction transistor and also discussed about the common base configuration and some of the important parameters associated with it, such as the current amplification factor and the expression for collector current. Now in today's video we will be discussing about the characteristics of common base configuration. Okay, characteristics means the relationship between voltage and current, or the VI curve or plot of the voltage and current relationship of bipolar junction transistor in common base mode. So as we know that a BJT has an input terminal and an output terminal. So obviously there will be two characteristic plots, VI characteristics, which are needed to be discussed so that we can understand the relationship between the voltage and current in a better way. So obviously for the input terminal or the input junction, we will have the input characteristics, which will be a plot between the input current and the input voltage, and the output characteristics for the output terminal or the output circuit, which will be a plot between the output current and the output voltage. So the common base configuration characteristics is of two types, the input characteristics and the output characteristics, and we will discuss each one of them separately. So first we will discuss the input characteristics. Okay, now we know that a bipolar junction transistor in common base mode is connected in the following way. Now the input circuit is the emitter base terminal. Okay, so here the input current is IE and the input voltage is VEB, the emitter base voltage, and the output current is IC, the collector current, and the output voltage is VCB. Okay, this is the output terminal, this is the input terminal. The input signal is applied here, the output is taken across this collector resistance here. So here we are clear about the input current and the input voltage, the output current and the output voltage. So now we can plot the VI characteristics. Okay, so first the input characteristics. So the input characteristics is a plot between the input current and the input voltage. Now for common base mode BJT, as I said earlier, the input current is the emitter current and the input voltage is the emitter base voltage. So basically it is a plot between the emitter current and the emitter base voltage at constant output voltage. Now the output voltage for a common base mode BJT is the collector base voltage, PCB. So the input characteristics for a common base configuration BJT is a plot between the emitter current and the emitter base voltage at constant collector base voltage. Now in this VI characteristics, the input voltage VEB or the emitter base voltage is in x-axis, the horizontal axis, and the input current or emitter current is in the y-axis or the vertical axis. Now here the variation in the emitter current for various values of emitter base voltage is plotted at constant or at a particular collector base voltage by keeping the collector base voltage constant at a certain value. Now if we look at the characteristic curve, especially this one at VCB equals to 0 volt, pay attention to this curve, we will discuss about that later. You will find that during this initial up to this point, okay, up to this point, there is variation in the emitter current with respect to emitter base voltage, but that variation is very less as compared to this point, beyond this point, where the emitter current increases rapidly with respect to the emitter base voltage. So that is almost beyond in 30 millivolt. So here overall the emitter current increases very rapidly with respect to the emitter base voltage. Now it is an indication of very less input resistance. It means the opposition to current flow is very less. So here we find that the input resistance of the common base mode BJT is very less, which is obvious because it's forward biased, but still the input resistance of the common base mode BJT is very less. Now as we increase the collector to base voltage, this curve which shows similar kind of a shape, it gets shifted slightly upwards. So here if we just connect the dots in dotted line, it will reach a negative VAB axis. Okay, so this will follow a similar pattern if we keep on increasing the collector to base voltage. So we can understand the input characteristics from this curve only at VCB equals to 0 volt, and when we increase VCB beyond and beyond, it will still follow more or less the same shape. So we can say that in a way the emitter current is almost independent of the collector to base voltage, the output voltage. The input current is independent of the output voltage, and the input resistance is very less because the emitter current is increasing very rapidly with respect to variation in the emitter to base voltage. So these are the two key points of the input characteristics. Normally the input resistance, okay, the input resistance is generally a few ohms. So here we will find an expression, mathematical expression for calculating the input resistance. So basically it is the ratio between the change in the input voltage, which is the emitter to base voltage, to the resulting change in the input current, which is the emitter current, at constant output voltage, which is collector to base voltage. You can note down this definition. So mathematically the input resistance is defined as the ratio between change in emitter base voltage to change in emitter current at constant collector to base voltage. So the general definition of input resistance is the change in input voltage to the change in input current at constant output voltage for any configuration of BJT. So in common base mode it is del VEB by del IE at constant VCB. Now as I said, the input resistance is very less, which is of the order of few ohms. Okay. So next is the output characteristics. Now the output characteristics of the common base mode BJT looks something like this. Okay, so the output characteristics is the same. It is a plot between the output current and the output voltage, but here there is one change. The constant parameter is not the input voltage but the input current. Okay, so never make the mistake of writing the output characteristics as the plot between the output voltage and output current at constant input voltage. It is at constant input current. Okay, so the input current is kept fixed and a plot is drawn between the output current and the output voltage. Okay, so the output characteristics for common base mode BJT will be a plot between the collector current, which is the output current, and the collector base voltage, which is the output voltage, at constant input current, which is the emitter current. Okay, this is the important thing, the constant parameter. It is the input current, not the input voltage, which was the case in the input characteristics. It was at constant output voltage, but here in output characteristics it is the constant parameter, which is the parameter which is kept fixed, is the input current, which is the emitter current in the case of common base mode BJT. Now this is the plot, the output characteristics plot. Here the output voltage or the collector to base voltage is in the x-axis and the output current or collector current in the y-axis. Now you will see that this portion in each of the plot, it is very less, it occupies very limited portion of the characteristics. So in this region up to this, which is normally up to 1 volt of the collector to base voltage, this point I am talking about, okay, this point, the voltage value at this point will be 1 volt or less than 1 volt. So only up to the collector base voltage up to 1 volt or less than 1 volt, the collector current shows some change with respect to change in collector to base voltage. But beyond that point, beyond that 1 volt point, the collector current becomes constant, flat. It shows no change with increase in collector to base voltage. That is, it totally becomes independent of collector to base voltage. Okay. So this shows that the output resistance is very high, means the opposition to flow of current is very high. Now as we increase the constant parameter, which is the input current or the emitter current, we see that the plot gets shifted, the constant value of the collector current increases, okay, it keeps on increasing, but the shape, the trajectory of the curve remains the same. The values of the constant collector current, it may increase, but the shape is the same, okay. So here the key points are that the collector current shows slight variation with respect to collector to base voltage up to a certain value, which is normally less than or equal to 1 volt. Beyond that value of collector to base voltage, the collector current becomes independent of collector to base voltage and acquires a constant value. As we increase the input current or the emitter current, that constant value of collector current increases, but the trajectory of the output characteristics, it remains the same. That is, keeps on increasing for the initial for a very small portion of the curve, and then it becomes constant. So this is the output characteristics of the common base mode BJT. Next, here the same things are written, you can note them down if you want. Now the output resistance. Now similar to input resistance, the output resistance is the ratio of the change in output voltage to the resulting change in output current at constant input current. Now for common base mode BJT, the output voltage is VCB, collector to base voltage, the output current is IC, collector current, and the constant parameter, again the constant parameter is the emitter current. So we can write the expression, the mathematical expression for output resistance as del VCB by del IC at constant IE. Okay, change in collector to base voltage to change in collector current at constant emitter current. Now as I said, the output resistance is very high for a common base mode BJT, and is generally, the practical value is of the order of several tens of kilo ohms. Okay, so here we have discussed about the input and output characteristics of the common base mode BJT. So in my next video I will discuss about the common emitter configuration, the basic circuit connection, the important parameters, and the characteristics of common emitter configuration, and then the common collector configuration. So I hope you liked this video. Please subscribe my channel Engineering Tutorial for more such videos related to electrical and electronics engineering. Have a great day. Thank you very much.